Good morning, ladies and gentlemen. I would like to say thank you for coming in my presentation. Let me introduce myself. My name is Retno Ayuda Pangestu. I am from Agronomy Department 11 Maret University. In this opportunity, I would like to present about the effect of application of control technique to the population damage intensity of onion caterpillar or Spodoptera exigua Hubner and yield of Shallots. Firstly, I would like to explain about introduction. Shallot or Allium ascolonicum L is one of the important horticulture commodities in lowland in Indonesia. So it has the potential to be developed as a farming business. But shallot production in Indonesia was lower than the shallot production in other countries, like Egypt. One of the obstacles to increasing shallot productivity in Indonesia is the attack of pests, that is onion caterpillar or Spodoptera exigua Hubner. Spodoptera exigua cause about 44.72% low damage and an increase of 81.19% before harvest, which caused damage to 10 until 12% of shallot bulbs. So, control is needed to prevent higher damage. The application of pesticide is method most widely used by farmers. However, the intensive use of pesticides has the potential to pollute the environment and pesticide residues in shallot products. The use of pesticides also causes a decrease or even loss of non-target insects. There are parasitoids, predators, and the other useful insects which cause a decrease in population and faunal diversity, resurgence of pest population, and development of pesticide resistance. To minimize these impacts, more environmentally friendly pest control techniques are needed. Mechanical pest control technique, that is covering with gauze or net, can be used as an alternative control to suppress the population of egg and larvae Spodoptera exigua and the intensity of damage to shallots. Secondly is material and method. This research was conducted in Wanasari, Brebes, Central Java, Indonesia. Research in the rainy season in October until December 2020. The variety of shallots was Bima Brebes, while the active ingredient of the insecticide applied were profenophos, carbosulfan, and metomil. The study was designed as a field experiment. Population of egg, larva, pupa, and imago of Spodoptera were recorded directly by visual observation on the 3 hills per sample unit. 30 sample units were randomly selected for each treatment. The observation interval was 5 days from plant age 2 weeks after planting to 1 week before harvesting by using a zigzag according to the method of Harahap and Kementerian Pertanian. Observation was carried out at 7:30 until 11 am. Damage intensity of Spodoptera was recorded based on the number of leaves attacked directly by visual observation on a sample unit of 3 hills. The kind of predators were recorded directly in the unit sample of shallots by using insect net. 15 double swings were selected randomly for each treatment. The observation was carried out at 7:30 until 11 am. Samples of egg and larvae collected from field are kept alive in the laboratory until parasitoid insect or the next stage Spodoptera emerge. The average population of egg, larvae, and imago of Spodoptera was calculated by the formula of Paparang. A sample linear regression test was also performed to identify the relationship between the larva population and the damage intensity of shallots. The ANOVA test was carried out to determine the difference between treatment on the parameter of the population, damage intensity of Spodoptera and the yield of shallots using Taki test and calculated using SPSS-23 software. Thirdly, result and discussion. The population of Spodoptera was found at 16 days after planting. Population growth increased in line with the age of the plant, and the peak of population occurred at 44 days after planting or before harvest. The highest population was recorded in the control plot and the lowest in the gauze covering treatment. There are explained in Figure 1. The results are in line with Marsadi's study, which also recorded population of Spodoptera larvae on shallots found until the end of the growing season. The population of Spodoptera larvae was not found in the shallot cover by using gauze, but was found in the insecticide treatment plot and also the control plot. The highest average population, 0.62 per hill, was found in the control plot, followed by 0.32 per hill in the metomil insecticide, carbosulfan plot, and the profenofos treatment. 3.2 Damage intensity of Spodoptera exigua. The result of the regression analysis showed that the population of Spodoptera exigua larvae had a significant effect of the intensity of onion caterpillar attacks. An increase in the population of Spodoptera exigua larvae will be followed by an increase in the intensity of damage to shallots. The result of this study showed that the average damage intensity of Spodoptera exigua between control treatment showed as a significant difference. The highest damage intensity of Spodoptera on shallots, 32%, was recorded in the control plot, followed by insecticide treatments metomil, carbosulfan, and profenofos. The intensity of damage was not recorded in shallots by the gauze cover treatment. Covering the shallot with gauze inhibits egg laying by Spodoptera exigua imago, so that no eggs and larvae were found in this treatment, and thus no damage intensity was recorded. 3.3 Kinds of predatory insect and parasitoid. The study did not find parasitoid insect in the egg and larva of Spodoptera. These results are similar to those recorded in Nurture 1's research, who also did not find egg and larva parasitoid of Spodoptera in shallots. Several types of predatory insects found in shallots are common predators such as spiders, dragonflies, bees, ants, and praying mantis. 3.4 Yield of harvesting shallot bulbs. The study noted that there was a significant effect of control treatment on the weight of yield of harvesting shallot bulbs. The average shallot bulbs treated with gauze cover was 50.83 grams per hill, higher than the application of profenofos insecticide, carbosulfan, metomil, and control. In the conclusion, divided into three numbers. Number 1. The control technique of Spodoptera exigua by covering gauze was effective to suppress the population of egg and larvae as well as the damage intensity of Spodoptera exigua than application of insecticide with active ingredients that are profenofos, metomil, and carbosulfan. Number 2. The average shallot bulbs in treated gauze cover was 50.83 grams per hill, higher than the insecticide application of profenofos, carbosulfan, and metomil. Number 3. The research recorded no insect parasitoid of egg and larva Spodoptera exigua found, while the predator found are generally the order of Diptera, Orthoptera, Coleoptera, and spider. Well, thank you for your kind attention to join the presentation. I hope this presentation will be beneficial for us. Good morning.